And thank you very much for our presenters. The presentations have been very insightful and very exciting to me. Thank you, Paul from Amtrak, John from AECOM now, previously Canadian Pacific Railroad. Actually, John also former president of ARIMA. Thank you for your presentation. Chad, a great presentation. Thank you for supporting this symposium. So now we'll enter into our panel discussion. As I mentioned before the presentation, you could enter your questions through the question answer feature or the icon there under Zoom. So we have several questions coming here. So what we will do is I will entertain a few questions first, and then I will give the forum to Jeff. So he will be taking care of the rest of the questions. So I think first question I have is for John. Yeah, this putting you at on the spot very beginning, but you mentioned about for the old railroad bridges, the dynamic they are designed for large dynamic increment compared to the modern rail traffic. So what has anything else contributed to the reduction in dynamic stresses?
Of course, the difference in the large dynamic increment is primarily due to not using steam locomotives anymore and having smoother running diesel electric locomotives. But lots of other things have contributed too. There's the removal of rail joints and the greater use of ballasted deck spans. Generally, a better understanding of the transition in track modulus, particularly from regular track onto bridges, particularly open deck bridges with a stiff deck. Improved train equipment has helped too. The improvement in spring technology, wheel truing devices and truer wheels, and of course, improved track maintenance equipment has also, and in practice, has also contributed to the reduction in dynamic stresses. And of course, as we mentioned earlier in one of the presentations, the wild or wheel impact load detectors, which enable the railroads to remove bad wheels, which are typically flat wheels, which would cause large dynamic stresses or stress ranges in the bridges. So those are all things that have contributed to the reduction in dynamic stresses today.
Yeah, thank you very much. So one question we have now next is Tony Donovan is asking for Chad, to Chad. The question is, as the GNW railroad, as the GNW railroad owner of St. Lawrence and Atlantic RR, which is currently leasing the 30-mile state-owned railroad between Auburn and Portland, Maine. Could you speak to the potential for shared use of that line with a commuter passenger train service, assuming a separation of use with freight at night and passenger during the day? This is a realistic question as the state of Maine develop a plan for which we would like to, for this use, we would like to demonstrate. Chad, that's for you.
Sure, thanks for the question, Tony. Unfortunately, so the way GNW is structured, St. Lawrence and Atlantic is part of our Canadian business unit. We have individual regions that are individual business units. So I can't speak to a lot of specifics on St. Lawrence and Atlantic, just because I'm not involved in their operations. But I can answer this in a little bit of generalities. Is that we host Amtrak's Vermonter on NECR. Reasonably similar operation there between NECR and St. Lawrence and Atlantic in terms of the type of railroad and the traffic. We do that, we do that successfully. They're there are, like I said in the presentation, there's some challenges with mixing freight and passenger. And we have had proposals for various other projects involving passenger rail on other G&W properties in the Northeast that have not materialized yet. But so unfortunately, I can't give you specifics on St. Lawrence and Atlantic, but we do it successfully in other places.
Yeah, thank you, Chad. I got a question here from Clary Kofu. So the question is this may be for all panelists or maybe Amtrak, Paul, whether you can take this question to begin with, and maybe John and Chad can chime in. The question is about the climate resiliency. So to plan for climate resiliency, what method do you recommend to best integrate resiliency into ROW maintenance and replacement of assets? The question is right of way maintenance.
Yeah, thank you, Ramesh. I'll take that first. Thanks for the question. Yeah, we do as Amtrak as a whole look at our resiliency and the effects of global warming with our risk management group and with our sustainability group. I know they've used consultants in the past to look at the forecast in the future, looking at the impacts of recent storms and 100-year storms. The exact methodology that they used, I can't speak to. I'm not aware of what they've used, but how that affects some of the projects. Two of the big projects I presented today, both the Susquehanna Bridge and the Portal Bridge, sort of benefit from that. Since we're making them fixed bridges, we're raising them several tens of feet above where they currently exist. It kind of hardens our infrastructure by placing them a little bit higher. On a more simpler scale, a lot of our projects that have CIH huts, CNS huts along the right-of-way, if those are in flood-prone areas, you might see on the Northeast corridor that we build these things on like a stilt foundation, bringing them several feet up above of the right-of-way in areas that have been known to flood or to take on high water. And also some of our electrical switching stations and our transmission places, and where the electrical power comes into our system. As you know, we're an electrical railroad. We're starting to make those more resilient as well, bringing them several feet up above the known floodplain and making them more hardened for what we're seeing in global warming.
Thank you. And Chad or John, would you like to chime in?
I don't have that much more to add to what Paul said. I thought Paul covered it exceptionally well. And in my experience with recent projects, when we've been bringing climate change issues into it, it's primarily affected the hydraulics of the bridge crossings. We're often, looking at higher water levels and flood propensity than we would have maybe 10 years ago.
So in some of the recent grant programs have placed a greater emphasis now, like the current round of CREASY fundings, emphasizing that climate change as one of the criteria for the program. One of the ways, one of the ways we try and meet that on the freight rail side is by when we maintain the track to a state of good repair. Slow orders are a big source of both consumption of diesel fuel for the trains, and then also grade crossing delay and when motors are sitting at crossings idling, the fuel consumption there. So aiming to maintain a state of good repair to avoid the unnecessary diesel fuel consumption and gasoline consumption. And then also, so we're seeing a move towards copper naphthenate. we're not using them. We're not using copper naphthenate ties on a widespread basis, with the exception of bridge ties. Some railroads are starting to move away from creosote and towards copper naphthenate. So that's I guess one other change on the maintenance away side that we've seen.
Thank you. I'm gonna go with one more question, and then I will give the floor to my co-moderator Jeff. So this question is for John. I'm directing this question to you. You mentioned when you talked about fatigue life of railroad bridges, you talk about the floor replacement for short span bridge. Now, for a longer span, has there been any work done, or what kind of effect do you think the replacement would have for the rail traffic? As you know, that may be longer delay in rail traffic.
That's a good question. Yeah, the example I showed in my presentation, I think, was for about 150-foot long through truss. Those are sort of, when it comes to truss spans on many of the railroads, there's a lot of them in that range of 150 to 200 feet. But yes, to answer the question, we have done a similar life extension on longer truss bridges. As a matter of fact, the opening slides and closing slides in my presentation showed a long truss bridge of the Canadian Pacific Railway across the Fraser Canyon in British Columbia. And a very similar system was used there, where the floor system, the stringers and floor beams, the hangers, and the end diagonals in that case were replaced following the fatigue evaluation of the bridge. With respect to the question on traffic interruption, of course, this is critical for both freight and passenger railroads. And that really precipitates the need to carefully plan these projects out, and in order to successfully strengthen and extend the life of a steel bridge. Typically, in my experience, the work has been divided, after careful planning, has been divided up into, let's say, 4 or 6 hour time blocks or track blocks to try to accomplish the work. Of course, in some instances, on maybe secondary lines, or where there is a larger 12-hour track block interruption to traffic required to replace maybe some major components, those are typically done at night, and they usually require at least in the freight railroad situation, you've typically got to give them a good 3 weeks or month if you advance. If you want the operating people, give them a good month of advance notice if you want to take the track out of service for 12 weeks. So yeah, the same kind of techniques can apply on longer spans, certainly.
Thank you. All right, I will give the forum to my colleague Jeff. Jeff, you want to take over for the other question answers? We still have about 10 minutes, I would say. Please do ask your question on the QA feature. We can still have several questions for our panelists. Jeff, you'd like to take it? You are in mute, Jeff.
Yep, I'm sorry about that. Thank you very much. I'll start with the first question that's still in the chat in the Q&A pod. I believe it is for Chad. You described the grants that you've been involved in, and do you believe partnering with passenger train services is beneficial in terms of attracting federal grants?
I would say it certainly has. In the slides, we looked at some of the grant projects that we've done on the New England Central Railroad, and a lot of those grants in Vermont were specifically related to NECR status as a host railroad for the Vermonter service. Yep. And I think with the current current administration is very supportive of passenger rail. So given that that's on passenger rail, there's a direct benefit with attracting those federal grants.
Right, and I might just have a follow-up of my own to that. Given the infrastructure deal and the billions that will be going to states through the FRA grant programs, are there requirements that the public-private partnerships you described require an equal share from the private sector? It seems that there may be more money from the states that will be available to be spent on such projects, that the private sector won't be able to keep up with a half share of that. Was that clear?
Yeah, it was. I guess I haven't fully, I don't know if any of us have fully digested all the results
clearly
from the infrastructure bill, but it looks like a lot of the funding from the summary I've seen, a lot of that funding from that infrastructure bill went to, was going to flow through some of the existing programs. They funded infra, raise, CRISI. So I guess, I guess I don't have a good feel for how that's going to play out with the matching fund requirements. That seems to change each NOFO. Each NOFO has its own requirements. But I can tell you, on the CRISI projects and the other federal grants we've applied for, we've been pretty aggressive at that matching fund contribution to try and strengthen those projects.
Yep. Thank you for that. I know it's early in the process. It just occurred to me as you were describing that. There's one new question in the pod for John. At what point is it more beneficial to do a complete bridge replacement rather than extensive bridge component, stringers, floor beams, hangers replacement instead?
That's a good question. Yeah, it usually would require a little bit of planning. As I mentioned earlier, these things require careful planning. Sometimes it depends on the location of the bridge. In many cases, depends on the type of bridge. In some cases, it is easier to go in and replace an entire span in a changeout. In other locations where maybe the access is a little more difficult, it's easier to go in with smaller items, smaller members, and do replacements and strengthening. So it really depends on the location of the bridge and the type of the bridge, and of course economics. One of the major issues would be doing performing cost estimates of different alternatives, and sometimes a replacement does come out top. Sometimes strengthening comes out as the most efficient and economical course.
All right, thank you. As a follow-up to that, when you were just talking about replacing small members, in your presentation, you made a point to identify that members with short influence lines are prone to fatigue cracking.
Mm-hmm.
What is the evidence that accumulated fatigue damage has been observed in these members?
Yeah, I think seeing the evidence of that, our bridge inspectors and our inspecting engineers find this. It's a good question. Due to the rail car axle spacing, members with shorter influence lines do typically experience a larger number of significant stress cycles, typically something like one per car. The evidence typically occurs in tension zones. We've seen evidence of cracking from poorly made rivet holes. Sometimes rivet holes were punched on older structures rather than reamed. That's a place where we've seen rivet holes come from. We've seen it in the bottom plates. Bottom cover plates have simply supported girders, particularly ones that were welded. A very common place where we've seen fatigue cracking is at the connections and floor systems where stringers pry against floor beams. We've seen cracking in the fillets of angles. Another location that comes to mind is at the top of hangers, as we showed in one of the last slides, replacing the end hangers in a Pratt truss, which is a member with a very short influence line because it supports the floor system, the floor beams directly, and that's a place where we've seen cracking. So we've typically seen evidence of cracking in members with short influence lines and in areas where there's significant tension. And we typically on the railroad I worked on, we would educate our bridge inspectors quite frequently and strongly on where to look for these things. So we have seen evidence of it.
Great. Thank you. I had one question for Paul. I see his camera's off, but I think he's still on. Your presentation included a graphic, and I can't remember what was being moved, but you were building a new tunnel with a new trajectory. Is that correct? Oh, he's in motion.
Yeah.
Paul, did you hear my question?
I'm sorry, which tunnel was the question about?
Yeah, the one that you were relocating. The Great Circle.
Yeah, that was the Baltimore, the BMP Tunnel in Baltimore.
Right, right. When Amtrak does projects like that of such magnitude, do you ever require acquisition of real estate? And how does that even work these days? I don't think public domain.
Yeah, there's quite a bit of real estate needed for that tunnel. I think well over 300 or 400 properties. We have a separate real estate group that's working on that. I think because it's federally funded, we do have certain rights to acquire things, but we're being very we're walking on eggshells to move that forward.
Right.
To say the least.
I imagine. That's what I was thinking when I saw the path that you were taking, and I said that looks like residential property, and I didn't. It was a personal question because I'd never involved in anything like that. So,
and plus, there's a single ventilation shaft, and that protruding up through the neighborhood and acquiring the property for that. But yeah, we're certainly walking on eggshells as that process continues.
Yep, I'm sure it is. And just to follow up to that, so and I know it's early, but I work for the government, so the infrastructure deal is burned into me. Amtrak is going to get a lot of money for infrastructure improvement, and I know you went through a list of a bunch of huge projects that you have, and I know there are others. I assume. It seems like it will be a very daunting task to add to your portfolio of these improvement projects with the limited staffing and capacity that Amtrak has. Is that likely to be an issue?
Well, most of the mega projects are built offline, so we'd be, mainly drawn upon, expertise of contractors and others, not the Amtrak workforce, to build much of it. We would like to additionally do some internal state of good repair projects, and we are staffing up, throughout the company to meet some of that demand.
Great, thank you.
Yep.
And let's see, I have one question here for John. You described that one of the benefits of CWR is reduced impact forces, but that CWR on open deck bridges can be a problem. What are some of the real problems with that?
Oh, yeah, that's correct. CWR does reduce the impact by getting rid of rail joints, of course. There are issues with CWR. On modern ballasted deck bridges, it's typically not an issue, but laying continuous welded rail across our old open deck bridges, which are typically timber ties on top of a steel girder, let's say. There's a careful balancing act, if we can put it that way, that has to occur. If those interfaces between the rail and tie, and again between the tie and steel girder or truss, are too rigid due to the longitudinal constraints, if it's too rigid, you can get quite high, very high stresses in the rail, which might induce track buckling on or just off the bridge, typically just off the bridge near where the expansion bearings are. If again, they're too flexible, there can be too much movement. And if you can get a lot of movement at the rail to tie interface, or again at the tie to steel span interface. Too much movement there can certainly damage fasteners that are fastening the rail to the tie, or the tie to the steel thing, to the steel girders, which is typically done by what they call hook bolts. So it's a careful balancing act when you're putting CWR across particularly long span open deck bridges.
Thank you. Thank you. And it looks like we've used up all the time that we were allotted. I want to just thank the panelists myself for your great presentations and a great Q&A. Thank you.